So let's have a look at that expression for acceleration of center of mass in a bit more detail. The expression which we got was this: acceleration of center of mass turned out to be summation of mi ai divided by summation of mi. Now if I break this up, if I write the numerator as independent terms, what it will look like is m1a1 plus m2a2 plus m3a3 etc. for n terms in the numerator, and let me keep the denominator as it is. It really doesn't make a difference. So summation of mi, and let's pay a closer attention to this first term, that is the mass of first element, the mass of first particle, sorry, not element, the mass of first particle multiplied by the acceleration of first particle. So you see that m1a1 is the net force acting on the first particle. And who could be exerting forces on the first particle? The first particle could be experiencing forces because of the second particle, because of the third particle, because of the fourth particle, and so on. And I want to write this entire expression here. So m1a1 is going to be force on the first particle because of the second particle, plus force on the first particle because of the third particle, plus force on the first particle because of the fourth particle, and so on. And there will be force on the first particle because of the nth particle, and then there may be some other forces on the first particle because of some external causes. So there may be forces acting within the particles, so the first particle will experience forces due to other particles. One or more of these terms may also be zero, that is also allowed. So maybe f12 is zero, that means the second particle does not exert any force on the first particle, that is completely allowed. But even if it exists, we can always write an expression like this. And finally we will include a term that will show you what is the force acting on the first particle because of somebody that doesn't belong to the system. So we will say that that's an external force. The second term can also be dealt with in the same way, m2a2, and that's the net force acting on the second particle. So what I can write for this guy m2a2 is, you see that m2a2 will be force acting on the second particle because of the first particle, plus force on the second particle because of the third particle, force on the second particle because of the fourth particle, plus so on, and force on the second particle due to the nth particle, and there will be a force acting on the second particle due to some external agents, like that. And I can write the expression for the third particle also in the same way. So you will see that m3a3 will be f31 plus f32 plus f34 plus so on, plus f3n, and plus finally f3 external, and the series will go on. So you can try to write such expressions for all these particles up to the nth particle. And finally maybe I will just write the final row. So what is that? mn an, that will be the final row, and that will be f on the nth particle because of the first particle, plus force on the nth particle because of the second particle, plus force on the force on the nth particle because of the third particle, and so on. And you are going to get force on the nth particle because of the n minus 1th particle, and finally force on the nth particle due to external causes. And we can now add them up. So if I add these expressions up, what I get is, on the left hand side I will end up with the numerator to this expression. But what do I have on the right hand side? You will see that on the right hand side I have got some force terms. Now force on the first particle by the second particle and on the second particle by the first particle are going to be related by Newton's third law, which means they must be equal, they must be opposite. So whatever I have for the force here, the green circle, will be exactly the value of force but in opposite direction for the blue circle, and these two are going to cancel out each other. So I can say that these two forces go off. And for the same reason, F13 and F31 will go off, F23 and F32 will go off, and here you have F14, here you will have somewhere F41, and that will also go off. So this guy will go off with some term here, they go off. And then you have F24, and here you are going to have F42. So the orange circles will also cancel out each other like that. And all of these terms will go off. You will see that F1n and Fn1 are also going to go off. So finally, what you are going to left with, what you are just going to have here in the expression on the right hand side is the sum of these external forces. So when I add up all these expressions, what I get is, so therefore, summation of MIAI is going to be summation of Fi external for I going from 1 to n. That's it. So if I take the force acting on the first particle because of the external sources, on the second particle because of the external sources, and so this can be written as F net external on the system. So let us try to write it as on the also, yeah. So this is the net external force on the system. So now what I can say is I have got this entire huge expression, and I can rewrite that in terms of only external forces. So therefore, acceleration of center of mass is the net external force on the system divided by, and you will see what was in the denominator here was this term, which is the total mass of the entire system. So total mass of all the particles comprising the system, or total mass of the system in short. So please keep this in mind. You can find out the acceleration of center of mass by only having a knowledge of external forces. Internal forces do not even matter. Now this is a very interesting result. What this means is that all the analysis that we have done till now for discrete particles, so keep in mind that we started off with discrete particles. Particles were not attached to each other. But now we can go on for big rigid bodies. We can say that there are objects which have a very large number of molecules present, and those objects will be such that the molecules will be interacting with each other. But if you take that entire object as a system, then the forces of interaction between the molecules, they become internal forces, and they appear nowhere in the acceleration of center of mass. So if you have got a big plate, or if you have got a big sphere or something, you can still find the acceleration of center of mass of that plate or sphere or maybe triangular lamina or something just by evaluating the net external forces on the system, and we don't have to know anything about the internal interactions. So that's a pretty interesting result. Now something more interesting than that. Now let us assume that the net external force acting on this system of particles is 0. So let us say, now first I think I should make a note of these two facts. Only external forces can cause the acceleration of center of mass. Internal forces cannot do it. And the second sentence which I can write is if along a certain axis the net external force acting on a system of particles is 0, then the center of mass will not accelerate along that axis. Will not accelerate along that axis. So this is interesting, and what this sentence says is that it can be individual. So you can have the net force, the net external force along x-axis being 0, but along y-axis it's still non-zero. Then the center of mass can accelerate along y-axis, but it won't accelerate along x-axis. So there can be those kind of cases also. So now say now if F net external acting on the system is 0, let us say, then acceleration of center of mass is going to be 0. Now if acceleration of center of mass is 0, that means the velocity of center of mass is going to be a constant. And in this there can be two cases. The first case is when velocity is 0, velocity of center of mass is 0 and is a constant. So what does that mean? That means that the center of mass was not moving initially, and because the velocity always is a constant, it's a 0, the center of mass never moves. So the center of mass was initially at rest and it remains at rest at the same point. So the interpretation of this is center of mass was initially at rest and remains at rest at the same point. And when I say same point, I mean same point in space. So that is also pretty important to know, that we will have an axis system, we will have x, y and z coordinate axes, and there in that coordinate system there will be a point that will be the center of mass, and the coordinates of that point will not change with time. And the second case here is when the velocity of center of mass is non-zero and it is a constant. So in this case the center of mass will keep on moving with that same velocity forever.